I'm afraid of that too. Thank you guys. All right, so if you were gone last Friday, there were 3 of you gone. We did just normal one sample t-test for means. So the difference for means is we use t, right? And so we've got degrees of freedom instead. And what else was different with that one? Large counts is different. It just has to be greater than 30 when we're doing means, or check the graph if it's less. All right, so now we're actually going to compare 2 means, and we're going to find the difference between those lists, and then we're going to do what's called pair T procedures, which is pretty much the same thing as T procedures, all right, but it's called pair T procedures. So, is caffeine dependence real? Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules, so they don't know which one they're taking. The order in which the subjects took caffeine and placebo was randomized. So you guys, we no longer have a random sample. Like, these are 11 volunteers. That's okay. We don't have to have a random sample, but we do have to have a random experiment where we randomly assign treatments. So that's why the order of whether they took caffeine or placebo was randomized, and they don't know which one they took. So at the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. Probably. The table below contains data on the subject's scores on the depression test. Higher scores show more symptoms of depression. For each subject, we calculated the difference in test scores following each of the 2 treatments, placebo minus caffeine. We chose this order of subtraction to get mostly positive values. So you can pick the order, just think about what your alternate hypothesis is going to be. So we're doing placebo minus caffeine, and then if we get a positive number, that means an increase in depression. Look at all those increases in depression. All right. So this is our score for depression with caffeine, with placebo. We subtracted, and we get that lovely guy. So why did researchers randomly assign the order in which subjects received placebo or caffeine? So why do random assignment? All right. So researchers wish to conclude that any statistically significant change in depression score is due to the treatments and not some other variable. So remember, random assignment assures that it's not some other variable that's affecting it. For example, the weather can make a difference on your depression score, and so if they randomize it, that helps account for that. Okay. Carry out a test to investigate the researcher's question. All right, so now we're going to see, is there significant evidence that there was a change? So this time we use mu d. All right, that's different. Mu d. So it's the mean difference. That's what mu d stands for. All right. So what's the null hypothesis going to be, you guys? What would we assume? The null hypothesis would be the least interesting one here. No change in placebo pill versus caffeine pill. So no change in depression. So that would be 0. All right, mu d is 0. What would be interesting is the increase in depression. So our alternative hypothesis would be greater than 0. The mean difference would be positive. All right. Don't forget to define your parameter and state the significance level. Some people forgot to state that on their homework, so don't forget that goes in the state part. So mu d is the true mean difference, placebo minus caffeine, in depression score for subjects like these. We'll use alpha equals 0.05. We have to say subjects like these because we did not randomly choose our 11 people they volunteered, okay? All right, so our plan part, the title of this test is different. The title is called a paired t-test for mean. Still a t-test, it's just called a paired t-test because we have two lists and then we are subtracting. So when we check random, we are not checking that we randomly selected our patients. We're checking that we randomly assigned treatments, okay? So that's what you're looking for with random. So yes, researchers randomly assigned treatments to subjects. So everybody did both, the placebo pill and the caffeine pill, but it was randomized who did what on what day. All right? So you're looking for random assignment. So in this type of problem, the 10%, we don't actually have to check that because we're not randomly sampling. All right? So since we're randomly assigning, the 10% doesn't apply. All right? So we don't need to do this. All right? Jake. Nope, you can skip it. Okay? And the last one we would check is large counts. All right, so we are looking at our N number. How many subjects did this study? Only 11. All right. And when you're doing large counts, that means we're going to have to check the graph, right? So does it matter which list is normal? Yes. So notice we've got our first list, our second list, and our difference. You only have to check one of those for normality. Which one do you think you have to check? The difference. That's the one we're using. So this is the only one that you actually need to check if it's normal by looking at the graph. You know it's going to be. I also learned today, even if it's not, you just say that you're going to proceed with caution. So pretty much you're always going to do the work. I don't know. Okay.
It was skewed, but whatever.
Yeah. All right, I did want to show you one thing you can do on the Inspire. So I typed in all the caffeine depression scores, all the placebo depression scores. So you guys, when you do your difference equation here, if you go to this equals box and we're doing placebo minus caffeine. So if you just type in placebo minus caffeine, your list, it'll do the subtraction for you. Pretty cool. Not that you guys can't subtract them, but it is kind of nice. All right, and then I've got a difference column. We're going to need to do one variable statistics anyways because we're going to need all the information. So I guess I'll do that while I'm here. Statistics, stat calculation, one variable statistics. Okay. And this time I want my difference. What did I do wrong? Oh, that will help. Cool. There we go. All right, and then we want to make our lovely graph, even though we're going to do calculations either way. Difference. All right, so, yeah, I like to look at this one. Yep. So, no strong skewness, no outliers. You guys, you do want to state that since there's no strong skewness or outliers, it's approximately normal. And then if there is an outlier, you can say there are outliers. You need to state that. So we will proceed with caution. All right. And of course, you guys do need to draw that graph. When you guys do these, please label your axes on those graphs, whichever one you draw. Okay. So no strong skewness, or... Okay, so now we're going to calculate our t-score. So if you were gone Friday, pay attention because this is for all means. So let me go back to my calculator and get my actual mean. So 7.36 is the mean of the differences. And we're subtracting what we assume the difference would be, which is what in this problem? 0. Good. Divided by. Our formula for our standard deviation or standard error is Sx divided by the square root of n. So we got to go find that guy, Sx. So 6.92 divided by the square root of 11. If someone could calculate that, or if you have your book open, that's fine too. Tell me what it is. That'd be great. 3.53. Okay, so there's our t-score. And now we have to do our t-statistic. So this one, you guys, on your calculator, if you were gone Friday, you might want to find it. It's t-CDF instead of normal CDF, right? So t-CDF, lower bound is this guy since it's positive, 3.53. Upper bound is 1,000 or bigger. And this time we don't have mean and standard deviation, we have degrees of freedom. What is our degrees of freedom for this test? 10. Okay. And if someone could calculate, or if you have your book open, that's fine. Tell me what'd you get? What is it? 0.0027. Yeah, I already wrote that on the next part. Yep. Cool. So, conclude, because the p-value of 0.0027 is less than alpha equals 0.05, we reject the null, which was that the difference is 0. So we do have convincing evidence that the true mean difference, placebo minus caffeine, in depression score is positive for subjects like these. Again, only for subjects like these. So the only new stuff, you guys, is you're always going to test the difference for normality. And you're going to always have pretty much 0 and then comparing to 0. And it's called a pair t-test for mean. You also want to check that the subjects or the treatments were randomly assigned to the subjects. All right. So just a reminder from Chapter 4, random selection allows us to make an inference about the population. So we did not have that. Random assignment of subjects to treatments allows us to make cause and effect conclusions. Make sense?